What if you could place a fake sensitive folder on your computer, and the moment someone opens it, copies a file from it, modifies something, or deletes it, you get an alert? That is the idea behind hacker traps and honey tokens. A honey token is a fake digital asset that looks important but has no real use. It could be a fake password file, a fake client document, a fake backup, or a fake private key. The goal is simple. Normal users should not touch it. So if something does touch it, that could mean malware, ransomware, an intruder, or someone snooping around. This is part of deception security. Instead of only trying to block attackers, you also place traps that help reveal suspicious behavior early. Think of it like a silent alarm. The attacker thinks they found something valuable, but actually they triggered a warning. Now let's test this idea using Centrix Shield. Centrix Shield is a Windows security tool focused on deception security, honey tokens, and suspicious file activity detection. For this demo, we are going to monitor a fake sensitive folder located here. Inside this folder, we can place fake sensitive files like a password backup, private keys, client data, or internal notes. These files will not contain real secrets. Never put real passwords, real customer data, or real private keys inside a honey token. The folder is only a trap. Now let's create the actual honey token in Centrix Shield. I'm inside the honey token section. This is where we can generate a new trap file and choose exactly what actions we want to monitor. First, I need to choose a name. For this test, I'm going to use sensitive underscore API underscore key. This looks like something an attacker might care about because API keys are often used to access services, cloud accounts, databases, or internal systems. But in this case, it is completely fake. Now I need to choose the location. I'm going to place it inside this fake sensitive folder. This folder looks like it belongs to a real development project, which makes the trap more believable. Next, I need to choose what actions Centrix Shield should monitor. I'll enable open because I want to know if someone opens the file. I'll enable copy because I want to know if someone tries to move or steal the file. And I'll enable remove because I want to know if someone deletes the file. For the file type, I'm going to choose a text-based file because API keys are commonly stored in text config environment. Now I click generate. At this point, Centrix Shield should create the honey token inside the selected folder. Now let's open the folder and check if the trap was generated. Here we can see the file inside the sensitive folder. This is the fake honey token. It looks like something important, but it does not contain real secrets. Now let's test it. I'm going to open the file like a suspicious user might do. The moment I open this file, Centrix Shield should detect that the honey token was accessed. Now let's check the email notification. After the honey token is accessed, Centrix Shield sends an email alert with the investigation details. Here we can see the honey token access alert. This email tells us that the honey token was accessed and that immediate review is required. Now let's inspect the clues inside the email. First, we can see the file path and the file name. This tells us exactly which trap was triggered. Next, we can see the host name. The host name tells us which computer generated the alert. Then we can see the Windows user. This helps us understand which user account accessed the honey token. Next, we can see the IP addresses. These can help identify the machine on the local network or understand where the activity came from. Then we can see the process name. In this test, the process is Notepad because I manually opened the file. In a real investigation, the process field can be very important. If the process was something unusual, like a suspicious script, an unknown executable, or unexpected tool, that would be a stronger warning sign. Finally, we can see the access date and time. This tells us exactly when the honey token was touched. So from one email alert, we already have useful investigation clues: which file was accessed, where it was located, which machine triggered it, which user account was involved, which IP addresses were connected to the machine, which process opened the file, and when it happened. That is the value of the email alert. Even if I am not watching the Centric Shield dashboard live, I can still receive the warning, review the details, and decide what to investigate next. The file itself is fake, but the activity around it gives us real security signals. And that is the full test. We created a fake sensitive file, placed it inside a realistic project folder, triggered it by opening the file, and then reviewed the email alert to see what clues Centric Shield captured. This is the main idea behind Honeytokens. The file is fake, but the warning is real. Honeytokens do not replace antivirus backups or good security practices, but they can give you an early signal when something suspicious touches a file that should never be touched.